Okay, here we've got another quadratic. It doesn't look like a quadratic yet, but when I go ahead and I distribute that 10x in, it will be that way. So I can move the 5 over first or second. It doesn't really matter. I'm just going to distribute first. So I'm going to take this 10x and I'm going to multiply it into both those. So 10x times x gives me 10x squared. And then I've got 10x times negative 2, that's negative 20x is equal to 5. Now, I never want to divide everything by a variable. Like, I won't want to divide everything by x, because x could be 0. So I have to be careful when I'm solving equations not to divide by the variable, because I can lose solutions. But dividing by a real number, okay, that's not a problem. When I say a real number, I mean, I know 0 is in the real number system, but the idea is I could divide everything by 5 here and make this a lot easier to look at. So if I divide everything by 5, I would get 2x squared minus 4x is equal to 1. Now we'll move the 1 over to the other side. So I have 2x squared minus 4x, okay, minus 1 is equal to 0. So now the question is, well, what are our solutions? Now, factoring this is a little bit harder because I have this leading coefficient. So I haven't done the quadratic formula yet, so I'm going to go ahead and use that here, although I could complete the square as well. I have to be a little bit more careful with completing the square. I would probably divide everything by 2 if I was going to complete the square, and that would give me x squared minus 2x minus 1/2 is equal to 0, and then I would go on from there. The problem with that is you have to deal with a fraction, and a lot of times students get a little bit, they have a little bit of anxiety with the fractions, so I'm just going to use the quadratic. So the quadratic formula is, since we're using the variable x, I'll write it as x equals, it'll be negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, well, what is a, b, and c? So once you have everything moved to one side, then we can locate a, b, and c. Don't try to do a, b, and c earlier. If you do it when it's not equal to 0, you're going to end up with some problems. So get it equal to 0 first. In our case, a is 2, b is negative 4, whoops, not 0, c is equal to negative 1. Okay, so now it's just going to be an issue of just plugging those in. So we've got x is equal to, well, negative b, so the opposite of b, well, b is already negative 4, so the opposite of negative 4 is positive 4. If you want to, I'll do it this way. You can write it in like that, negative b, but a negative and a negative is going to make it positive. Then I'm going to have b squared minus 4 times a times c, and the whole thing is going to be over 2 times a. It's important that we put the whole thing over 2 times a and not just the square root piece. So x is going to be equal to 4, like we said, 4. Okay, plus or minus the square root. So 4 squared is 16. Now I have minus, and this number is going to be negative. So it's going to end up being plus altogether. So really it's minus 4 times 2 times negative 1 is negative 8. So it's minus a negative 8 all over 4. Okay, so this is going to give me x is equal to 4 plus or minus the square root. 16 plus 8 is going to be 24. All over 4. Now the 24 we should be somewhat careful with, because even though the square root of 24 isn't a perfect square, we can rewrite it to pull a little bit out. And so 24 is divisible by 4, which is a perfect square. So what I'm going to do is, to reduce this, is I'm going to look to see, is 24 the product of a perfect square and another number? When I say product, multiplication. So is 24 some perfect square times another number? And it turns out it is. So kind of as a side note, I'll just do it over here. The square root of 24 is the same thing as the square root of 4 times the square root of 6. Square root of 4 is 2, and the square root of 6 we can't do anything with. That's as simple as it gets. So we're going to end up with 4 plus or minus 2 square roots of 6 all over 4. Now notice in the numerator, the top part here, I can factor out a 2. So I could write this as 2 times 2 plus or minus the square root of 6 over 2 times 2, right? Because that's 4. And so because I've got multiplication in between, I can cancel. So that'll give me x equals 2 plus or minus the square root of 6 all over 2. And so we have two answers there. One answer is 2 plus the square root of 6 over 2, and the other answer is 2 minus the square root of 6 over 2. Notice that I didn't write these from smallest to largest, and that doesn't matter. So what do I mean by that? Well, this one here is actually on a number line. It's actually on the left side of this. They'd be like writing like the number 5 and then the number 1. Okay, well, yeah, 5 is larger, and we usually write the larger numbers to the right. But with sets, with a notation here like this with sets, the order inside of the set doesn't matter. A set is kind of like a bag that you're holding objects in. It doesn't matter the order, it just matters that they're in the bag. And so unlike interval notation and stuff, the sets won't matter, so I can write them like this. That's perfectly fine. Okay, so these are our two solutions to this original equation.